Ever wondered why every 4 years we get an extra day in February, marking what we call a leap year? What's the science behind this peculiar calendar adjustment? Well, it's all about the way our planet moves. You see, it takes Earth about 365 and a quarter days to complete one full orbit around the sun, but our calendar year is only 365 days long. If you do the math, that's an extra quarter of a day that we're not accounting for. Over time, these quarters add up. Every 4 years they total an extra whole day. So, to prevent our calendar from drifting out of sync with the Earth's orbits, we add this extra day to our calendar. We do this in the shortest month, February, extending it from 28 to 29 days. So the leap year isn't some random event but a necessary adjustment to keep our calendar in sync with Earth's revolutions around the sun. Now that we know what a leap year is, let's delve deeper into the science behind it. Leap years exist because of the imperfect harmony between our calendar year and the time it takes for Earth to orbit the sun. You see, Earth doesn't take exactly 365 days to make its annual journey. Instead, it takes about 365.24 days. That's nearly a quarter of a day more than our calendar accounts for each year. So, what happens with those extra 0.24 days? Well, they accumulate. After about 4 years, we've gained nearly an entire extra day. To keep our calendar year in sync with the solar year, we add this extra day to our calendar every 4th year, and thus, the 29th of February is born. But there's more to this celestial dance. As Earth orbits the sun, it doesn't do so in a perfect circle. Instead, its path is more of an ellipse or an elongated circle. This means that at certain times of the year, Earth is closer to the sun, and at other times it's farther away. The point in Earth's orbit where it's closest to the sun is called perihelion, and it usually occurs around the 3rd of January. On the other hand, the point where Earth is farthest from the sun is called aphelion, and it typically happens around the 4th of July. These variations in distance impact the speed at which Earth travels along its orbit. When closer to the sun, Earth moves slightly faster, and when farther away, it moves a bit slower. This seemingly minor discrepancy is another factor that contributes to the necessity of leap years. It's all a part of our ongoing attempt to keep our human-made systems of time in harmony with the rhythms of our planet and the cosmos. So, in essence, the leap year is our way of compensating for the Earth's imperfect orbit around the sun. Imagine we decided to ignore this extra 0.24 days and stopped adding an extra day every 4 years. What would happen? Well, the consequences would be quite interesting. Our calendar year, which is currently in sync with Earth's orbit around the sun, would begin to drift. This wouldn't be noticeable right away. In fact, it would take about 100 years for our calendar to fall out of sync by a mere 24 hours. But let's fast forward a bit. After a few centuries, we'd start noticing some peculiar changes. Our seasons would be shifting. Picture this. You're celebrating Christmas in July, not because it's a fun, off-season party, but because it's actually winter. Yes, ignoring leap years would eventually lead to a complete flip of the seasons. But that's not all. Agricultural practices, which rely heavily on seasonal patterns, would be thrown into chaos. Imagine farmers trying to grow crops in the wrong season. The impact on wildlife would also be severe, as many species time their behavior to the seasons. Of course, we could always adjust our calendars to correct the drift, but that would be quite a hassle, wouldn't it? The leap year, as it turns out, is a simple, elegant solution to keep us aligned with Earth's orbit and the changing seasons. As you can see, the leap year is not a trivial matter but a crucial part of our calendar system that ensures our daily lives stay in sync with the natural world. So, we've learned quite a bit about leap years today, haven't we? To recap, a leap year with its extra day is a product of Earth's elliptical orbit. This added day keeps us in sync with our planet's rotation. The phenomena of perihelion and aphelion show us the extremes of this orbit. Ignoring leap years would throw off our calendars and have significant impacts over time. Next time, February 29th rolls around, remember the fascinating science that gives us this extra day. Thanks for watching.